when we remove this proportionality sign, will take a constant, right? So it becomes R is equal to rho L upon A, right?
Yeah.
This rho is known as constant of resistivity. Constant of resistivity. Right? Depends upon material of conductor, and temperature, right? And this resistance depends upon resistance depends upon length of wire, cross sectional area of the wire, cross sectional area of wire, right? And material of conductor, and temperature, right? Do you understand this? Hello.
Yeah.
You understand this?
Yeah, I do.
No?
I do.
Okay. Okay. Suppose there is a condition. Suppose length of wire becomes 3 times. Then what will be the new resistance? Can you tell me? length of the resistance increased 3 times, right? But so what will be the new resistance? My question you is readable to you?
No,
Not readable.
no.
Its picture is blur.
Yeah,
When I'm asking you that, so why not you told me earlier? Still, it is not correct.
no, I can't see a question.
Pardon?
Could you just dictate the question?
Okay, so question is that. Okay, can I rub all this?
Yeah, you can have that.
This red one. Okay, I do rub all these, right? I do rub all these. Okay. Now question is that if if length of a conductor of a wire increase 3 times 3 times of initial length right, then what will be what will be new resistance? What will be new resistance? Now it is visible.
Yeah.
So how you will do this? Will you able to do this or not? Tell me first.
I don't think so.
Okay. Let initial resistance be R. Length L. And cross-sectional area be A. Right? Rho is resistivity of material. Resistivity of material of wire. Material of wire. So we can write R is equal to rho into L upon A. Say this is R1, right? Now you increase the length. When you increase the length, then what happens? This length becomes 3L. 3 times na, of initial.
Yeah.
So if it is L1, it is don't go in that. Forget about it. Okay. Length becomes 3 times, so it becomes 3L. When you stretch anything, then what happens? Its cross-sectional area will be reduced or not? When you stretch a wire, then what happens? When length is increasing, cross-sectional area decreases. Right? So its cross-sectional area becomes A by 3. Right? Then we have R2 becomes rho 3L upon A by 3. Right? Right? Is this correct? If I write R1 upon R2, it is rho L upon A upon rho 3L slash upon A slash 3. Right? So what happens? This rho and rho is cancelled out because material of wire is not changing. Right? So you get something like that. L upon A into this 3 will go up, it becomes 9L. No, 3 go up, so it becomes 9 and A will go. So A upon 9L, like this. This A and A is cancelled out, L and L is cancelled out. So you get 1 upon 9. Right? What is the meaning of it? R1 upon R2 is equal to 1 upon 9. Or we can say R2 will be 9 times of R1. So resistance will increase 9 times of initial resistance. I hope you understand.
Yeah.
Still not.
No, I did.
You understand. Okay, great. Now you study about combination of resistors. You study about combination of resistors.
No, I don't think so.
Is it in your syllabus?
I don't think so.
It is not in your syllabus. Anyway, I hope I should tell you. Acha, you know a simple circuit? What is a simple circuit?
A simple circuit is like
Huh. Simple circuit is nothing. It is arrangements, right?
yeah.
There is, we have taken, this is one battery we have. This is battery, right? There is wire. This is positive terminal. This is negative terminal. So current will flow in this direction. Here is ammeter. Ammeter. Device. Device. Measure. Measure flow of current in circuit, right? After this device, there is a bulb. This is a bulb, right? This is consumption point. This is consumption point, right? Then we further continued, right? And there is a, this is called rheostat. Rheostat offers variable resistance, variable resistance in the circuit, right? This is offering variable resistance in the circuit. So this is, current is flowing in this direction. Now there is a switch, key, control flow of current, flow of current, right? And it is attached with the rheostat. Suppose here, so minimum resistance is there, right? And there is one more device that we call voltmeter, right? Voltmeter. Voltmeter. Measure potential difference across the terminals of battery. Across terminals of battery. Right? This is voltmeter. Do you understand?
Yeah.
This is normally in a circuit are there. Right? Now, if we talk about combination of resistors, so they are of two types. One is like this. This is positive, this is negative, this is, this is emitter. There are resistors. This is resistor 1. Then we have resistor 2. Then we have resistor 3. There is a key in the circuit. Key. And this is attached with the, like this. Like this. This is R3. Right? Potential difference across the terminal of battery is V. Right? And current flowing in the circuit in this direction from positive to negative terminal, right? That is I. Right? There is a condition. Here is the potential difference is V. Right?
Yeah.
But here will be potential difference V1. Here will be potential difference V2. Here will be for potential difference V3. Right? And sum of all these potential difference V is equal to V1 plus V2 plus V3. Right? Sorry. Total potential difference is sum of all these potential differences. Get my point?
Yeah.
So what will be the value of V1? Ohm's law, you know, na? Ohm's law, that is V is equal to IR.
Current and resistance.
Right?
Yeah.
So here is V1 is equal to I into R1. Here is V2, that is I into R2. Here is V3, that is I into R3, right? So V1 is I into R1, V2 is I into R2, V3 is I into R3, and when you put the values here, so V is equal to IR, you know that from here. So we can write here I capital R is equal to I into R1 plus I into R2 plus I into R3, right? You have taken I as a common, so I capital R is equal to I you have taken as a common, it becomes R1 plus R2 plus R3, right? This I and I is cancelled out, then what do you get? Total resistance is equal to R1 plus R2 plus R3. Getting? Is it okay? It means this is called in series. This is resistors in series. Head to tail connect, right? And in series net resistance get increased. Increased. Do you understand all this what I told you here?
Yeah.
What I said, when we are connecting in series, then the net resistance get increased, right? Another way of combination is, it is like this. This is positive, this is negative, this is ammeter. Current is flowing in this direction, right? Like this, here and here. R1, here, R2, here, R3, right? There is a key, and this is the circuit. This circuit completes. So current I is flowing in the circuit, right? And potential difference across the terminal of battery is V, right? And this is I current is entering and I current is coming out, right? So potential difference across the term in parallels, potential difference across the terminal of resistors will be V. Same. Here is V, here will also be V, right? It is constant. What is here? What is same is here. That's why in domestic wiring we are using in parallel way, right? So at every point we get the same potential. This is we call resistors in parallel. They are in parallel. Get it? I hope you get. Right. Now, what we do, man? This is R3. Potential difference is same, right? And resistance is fixed. So current is varying. In which wire resistance is more, current will be less. If resistance is less, current will be more, right? So if I say I1 is equal to V upon R1, I2 is equal to V upon R2, and I3 is equal to V upon R3. Getting?
Yeah.
Here is entering, current I is entering from here, and current I is it coming out. Total current is same. So we can say I is equal to I1 plus I2 plus I3. Right? You said V is equal to IR. This is what? Ohm's law? So I is equal to V upon R. Right? So here we can write V upon R is equal to I1 is V upon R1 plus V upon R2 plus V upon R3. Getting?
Yes.
So now V upon R, we have taken V as a common. So we get 1 upon R1 plus 1 upon R2 plus 1 upon R3. This V and V is cancelled out. We get 1 here, right? So in parallel, what happens? Net resistance is 1 upon R is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. Right? This is the net resistance. And in parallel, net resistance of circuit decreased. right?
Yeah.
What I told you, in series, net resistance of the circuit get increased, right? But in parallel, net resistance of the circuit get decreased. So whenever we have to reduce the net resistance of the circuit, we arrange resistors in parallel. And when we have to increase the resistance, then we arrange them in series, right?
Yeah.
I hope you understand. All the things are visible to you.
Yeah, they're visible.
Oh, great. Thank you. So now